Hello and welcome to What the Math. Today we're going to be continuing our orbital math calculations and trying to do a docking maneuver using precise math, or somewhat precise math, because I am using a lot of rounding in this. So this is my docking station that I want to connect to this spaceship that's called Untitled Spacecraft, because I forgot to name it. Now this one is actually about 72 kilometers above Kerbin, and this one is about 103 kilometers above Kerbin. And they do have a different orbit, so I need to do two things here. One is I need to find a precise moment when they realign, basically sort of like, or almost right now, but actually I kind of missed the moment when they were aligned together. And because this spaceship is moving faster, it's actually covering or moving around orbit a little bit faster than this spaceship. So what I need to today find out is where do I have to align them so that this spaceship, when it's changing its orbit, will move to the new orbit in the precise moment when this spaceship is actually here. So in other words, let me just draw this for you. So this is Kerbin, and here is my my spaceship, or my station that I want to dock with. And I'm going to use yellow for the other spaceship, and this is the spaceship that I want to dock to my orbital station. Now they're moving in this direction, so they're moving this way, and when they're aligned like this, when they're actually aligned right under each other, this is something that we found in the previous video. When they align like this, if I try to change my orbital, or basically my orbit, if I try to transfer orbits right now, what will happen is, because this spaceship is moving slower, in the time that it takes to transfer, it will cover this much distance. This is how much it will cover. But this spaceship is moving faster, so in the same time, it will cover a little bit more distance. It will be in a new orbit now, but it will be actually ahead of my other spaceship, so that's not exactly what I want. So what I need to do is I need to find a moment, which is usually right behind this station, somewhere over here, when I need to start this orbital transfer, so that by the time that it comes to the new orbit, it's going to be an exactly precise moment where my other station is. And to do this, what I need to do is I need to find this angle right here. This is not exactly straight, but this angle right here. I'm looking for this angle between... this is horrible. Let me just redraw this. I'm looking for the angle between this and this. So this angle is what I'm looking for. And how do I find this? Well, let's just actually work on this. Let's try to figure out what this angle has to be for me to use this orbital transfer. And to do this, we're going to be taking a look at something called, I'm going to call it arc speed, or arc length speed. So essentially, let me just show you what I mean by this. I'm going to use my protractor here and show you visually what I mean. So this is my orbital station that I want to dock with. And so this orbital station is orbiting like this, and it's changing the angle. Let's just say every second it changes by about 1 degree. Just a rough estimation, 1 degree per second. Now, this right here is my other docking station that I want to dock with it, and it's changing its angle a little bit faster at about 1.07 degrees per second. This is something that we found in the last video, so it's a little bit faster. Now, what I am interested in is the difference between those two. I'm interested in the difference of arc length speed between these two stations, because what this will give me is, it will give me this the speed that speed of arc length right here that can help me estimate how long it takes for this station to actually move in a certain time period. So basically, if my top station right here moves this arc right here of 10 degrees in 10 seconds, so it's 1 degree per second, and that's very rough, I don't think that's even correct, but let's just assume that it's 1 degree per second, and my other yellow station below it moves at about 1.07 degree per second. The difference in arc speed here is going to be exactly, so you basically, you subtract them, it's going to be exactly 0.07 degree per second. And that's not exactly correct, but this is how you would find this. So let's actually look for this number so that we can then use it to find all of the needed information for us to realign them together, or basically to do our orbital transfer. In order for us to find this, we need to actually look at the orbital period of both objects, and the orbital period formula is right here. This is the formula we used last time, so it's 2 pi square root of a to the power of cube, to the power of 3 divided by mu. So this right here, this is the distance from the center of Kerbin in meters, and this is the gravitational parameter that is available to us if we click on Kerbin and look right here. So this is it right here, 3.532 times 10 to the power of 12. So I'm going to quickly calculate the orbital period for both of these objects. And these are the answers. So 1970 seconds for the top object, so for my main station that's about 100 kilometers above Kerbin, and then 1841 seconds, this is seconds and this is seconds, for my object that I want to dock with it. Now let's take a look at what we need from this. So basically what this means is that for my yellow object, for my bottom station, in 1841 seconds it makes a complete circle, so 360 degrees in about, that's not a circle, in about 1841 seconds. This top object does the same thing in 1970 seconds. Now what I'm curious about is what is the difference in arc speed. So how do we find this? Well, let's take a look at this bottom object. In 1841 seconds, this blue object will cover approximately this much. It will not cover the whole circle yet. Now in 1970 seconds it will cover the whole circle, but by that time this object will have moved a little bit ahead. It will actually have covered another arc. And this arc right here will show me, if I find this arc, it will actually show me the arc speed difference, or difference of arc speeds. So this is what I'm looking for. So how do we find this? Well, first of all, we find the difference between these two numbers, and this is going to be 129 seconds. And so what does this mean? And so this means that this right here is 129 seconds. Now what I'm looking for is how many degrees will the spaceship cover in this time. And how do we find this? Well, we find this by first looking at the ratio of 129 to original value of 1841. And then we're going to introduce the circle here and basically multiply everything by 360 degrees. And this answer is roughly about 25 degrees. So what does this mean? This means that every orbit, this yellow spaceship, the bottom spaceship, will actually cover a 25-degree arc and will catch up with the blue spaceship, or will move away from the blue spaceship by 25 degrees. So let's go here, I'll show it to you visually. I'm gonna zoom in on this spaceship. And so every orbit, so after one orbit, the difference in this angle right here is going to be plus 25 degrees. So let's actually look at it. So one orbit. And stop around now. So okay, so this has increased by approximately 25 degrees. And this is actually something that we can use to define various things, including finding the realignment of two orbits, and specifically we can now use this to find our Hohmann's maneuver angle. Now how do we do this? Well, this is what we need to find. We need to actually look at the Hohmann's maneuver formula first. And this is actually from Wikipedia as well. So Hohmann's transfer orbital time right here, the formula for it is this. It's radius 1 plus radius 2, so this is our value a1 plus value a2, divided by 8 mu's, which is the value that I showed you before. It's right here, 8 GMs, these 8 things. And then oh, this also has to be cubed, and then square root of that and multiplied by pi. So it does look pretty complicated, but this will actually give me time in seconds of how long it takes for my bottom spaceship, for this docking station. So essentially what this shows me is how long it takes me for this spaceship to go from its old orbit of 71 kilometers to a new orbit of about 100 kilometers. So let's find this number. It's going to be in seconds. So let's start with R1 plus R2, and this is about 703,000. So this has to be in meters, plus 672,000. And the answer is 952, and this is almost 953. 953 seconds. In other words, for my yellow spaceship to get into the blue orbit, it will take it about 953 seconds for this maneuver. Now we also know that it takes the blue spaceship, the top spaceship, 1970 seconds to orbit. So what we're looking for here is, we're looking for the ratio of 953 to 1970, which will give us the basically the ratio of orbit that this spaceship will make in the time it takes for the yellow spaceship to arrive to it. So here, this is going to be approximately 0.48. So essentially, in this time, in the time that it takes the yellow spaceship to do a Holmes maneuver, the blue spaceship will have covered 0.048 of its actual orbit. So not exactly half, but almost half. So it's sort of like almost half of its orbit. And we can now use this value to find the necessary angle for us. So we're going to be able to find this angle using this. So if we multiply this number by this number, it will give us the angle that we need. So basically 25 degrees, which is the difference in arc after one complete orbit, multiplied by 0.48 will give us roughly about 12 degrees. So in other words, what this all means, what this number here means, is that when I'm going to erase this just to make another picture. When my blue spaceship orbiting in this direction and my yellow spaceship orbiting in this direction, when they have approximately 12 degrees between them, right here, and this spaceship is behind this spaceship, this is when I should start my Holmes maneuver. And if everything goes right, by the time that this spaceship arrives into its new orbit, it will be right next to the blue spaceship. So this has to be about 12 degrees. It's actually relatively hard to calculate this manually in Kerbal Space Program, but I'm going to use my protractor to do my best. And since in the previous video we found that it takes about 14 orbits to realign, 14.3 orbits, actually 14.7 was the actual value. We need to wait for 14 orbits for them to realign, and then try to have this spaceship about 12 degrees behind my orbital station. So let's just wait for this and wait for this to happen. Alright, so this is kind of looking good. So it seems like it's approaching the angle I need. This is a docking station, this is a spaceship I want to dock with. Let's use a protractor to try to estimate if this is approximately 12 degrees. And because my protractor is not the best in the world, I'm only estimating, I'm not actually getting a correct value here. But basically it's between 239 and 220. So this is about 19 degrees. I'm going to go ahead and I don't want to say cheat, but I am using a space engineer that gives me precise numbers. So I'm going to actually zoom in on my spaceship right now and use the space engineer to find a specific angle. And it's the angle right here, it's the phase angle that I'm looking at, and it's telling me that it's currently 90 degrees. So I was pretty accurate there with the protractor. But basically, as soon as this reaches 12 degrees, I'm going to start blasting my engines, and I should probably actually start setting my maneuver as well. And I'm going to blast my engines until my orbit, my old orbit intercepts with the new orbit. So let's wait until this is 12 degrees. Alright, so my phase angle is approaching 12 degrees. It's very close to what I need. And right here, I'm going to start setting a maneuver node and reach a new apoapsis of about 103 kilometers. And it's already giving me an intersect right there, but it's not perfect yet. Alright, I missed it by a little bit. I was actually doing my maneuver nodes a little bit too long, so let's just start blasting our engines by only about 25 meters per second. So I hope I got my right engines on. There we go. I'm gonna blast this by 20 something meters and then see how it goes. I should be approaching my other space station if everything went right. Okay, so this is my new intersect right here, and it says that I'm going to be passing by. Alright, so it's about 64 kilometer separation. Now I can obviously play around with this, make it a little bit more accurate, but essentially this is really it. This is how you do it. So now all that's left for me is to try to adjust this a little bit. The reason why it's actually not precise is because I was using rough numbers and rounding. But if you use a space engineer or flight engineer and you try to make this a little bit more accurate, you can actually get some really precise numbers and literally approach this within like few a few kilometers maximum. The other thing I actually did not realize is that my orbits are vertically misaligned, so I need to actually correct for that. That's one of the reasons why there's so much separation between them. So I'm gonna do this first. I'm gonna correct the vertical alignment. Okay, so here we go. I'm in my new orbit right now, and I found an intersect at around 7.7 kilometers. And this is actually pretty accurate. So right here, I'm gonna pause the game in a second, or basically stop accelerating it and start manually approaching the station, because I think this is good enough. I think this is actually quite acceptable for me, and I can start manually trying to dock with the station that's right there. Now obviously, if you want to do this professionally, you should be just waiting for your spaceship to approach this slowly, but I'm gonna do it rough way and just blast my engines toward it and essentially approach it at full speed ahead. And so to do this, I need to realign my yellow marker, this marker here, with this purple thingy here. So I'm gonna do it this way. I'm gonna blast my engines this way. Basically decelerate first, change my speed compared to the target, and then start moving my yellow marker toward the purple thingamajig. Now this is not the best way of doing this, but this is kind of like the faster, more rough way of trying to find the docking location. Here we go. So we're approaching the target at 10 meters per second right now, so I can accelerate time and wait for me to get closer to it. Alright, I'm only about 500 meters away, so I'm going to start slowing down. I'm going to actually a little bit too fast. So let's slow down and start approaching the station. At about 2 meters per second, that's good enough. I unfortunately forgot to put lights on this, so I don't really know if I can see the station, especially in the dark, but we'll see if we can see it. I do have two docking ports, one bigger one right here and one smaller one on top. I'm gonna try to dock with the bigger one if I can, but if not, then maybe have to use the smaller one. Alright, I can kind of see it now, so now it's time for us to start docking, or realigning our ship so we can start docking. I do have RCS as well, so I'm going to enable that, and this will help us do this somewhat more professionally than before. And if you want to start docking with the station, I don't actually know how it's aligned, I cannot see from here, but this is the docking mode that you should probably enable so that you can start moving your spaceship sideways and vertically and so on and so forth, because this will make it a little bit more precise when you start docking. I think this is actually, I don't know if this is the front or the side. I do see the solar panels though. Oh, I should have really brought the lights, I didn't think about it. It's all your fault, Derby Kerman, you told me not to bring the lights. Now the reason I have two engines on two sides is because I can now use my control panels and my engines to basically decelerate and accelerate as I need. So for example, right now I enable these engines here, and if I accelerate, it decreases my speed. If I re-enable my other engine, I can now accelerate using the same thing. So this is actually a pretty cool design where I have three tiny engines on both sides, and my total delta V is approximately 3,000 meters per second, so it's actually quite a lot. It's quite a lot for me to dock and to even go to the moon if I wanted to. Uh-oh, that's not good. That is not good. Okay, there we go. Okay, so I sort of see it, but I think I'm pretty sure I'm approaching from the side. Yeah, that is the side. I'm not approaching from the right angle. So I need to redo this. I'm gonna use my RCS. I do have a lot of RCS fuel, so I might as well use it up. I'm gonna approach from this other direction. Oh boy, this is way too dark. I'm gonna wait for the sunlight so I can actually see where I'm going. I really do not see anything right now. I don't have the mod for the orbital docking, unfortunately, because I usually prefer to do this manually, but I really should have used the mod for this, because it's so much easier to see. I do know I have to align myself with this, but I don't know how accurate this is. Alright, here comes the sun. Hopefully I'll be able to see things a little bit better now. And I'm totally off target. I didn't even realize how off target I was. Oh, I'm going a little bit too fast, but I think this is possibly the best I can do right now. Oh, a little bit here. No, a little bit higher. A little bit slower. Slow down, slow down. There we go. Okay, we docked. Perfect. Alright, so this is it. I think I'm going to pause this here. Thank you for watching. Hopefully this was useful for you. And this is my new orbital station. I do have 2 more ports here where I can attach other things. But this is basically a new model of a spaceship I was trying to develop. Something I can assemble in orbit. One with a science center right here, science lab. 4 people on it that can use science lab. And then 3 engines with a total delta V. How much do I have left? I have 2000 delta V left. And also quite a lot of RCS. I do have quite a lot of monopropellant left, so I can actually use this station for various things such as orbiting around different planets. I can possibly even reach the moon and possibly even land on the moon. And definitely can land on Minimus and come back from Minimus as well. Okay, thank you for watching. This has been What the Math with math behind orbital docking. Hopefully this was useful. And please subscribe. Bye bye and game you later.